Welcome to this lesson on Dynamic Routing Gateway. It's time to revisit the deck. Let's get started. What is a Dynamic Routing Gateway? It's a virtual router which facilitates communication between on-premises network and virtual cloud networks. And there's a concept of attachment. So in DRG, basically we can have different types of attachments, and every attachment is going to have its own associated route table. And we have discussed in the whiteboarding that by default, whenever you create a dynamic routing gateway, two route tables are created. We also talked about the concept of static route and dynamic routes via import route distributions. So inside a dynamic routing gateway route table, you can have both static routes and dynamic routes. And you can attach which type of resources to a dynamic routing gateway: VCNs or virtual cloud networks, remote peering connections, site-to-site VPN IPsec tunnels, fast connect virtual circuits. And apart from this, you can also have cross-tenancy attachments and loopback attachments. So this slide talks about the different types of attachments that we can have with dynamic routing gateway. I already talked about it: VCN, remote peering connection, IPsec tunnel attachments, virtual circuit attachments, and loopback attachments. So in this diagram, you can see that the DRG is in the middle. There are VCN attachments, RPC attachments, and this is basically depicting the different types of DRG attachments. So let's also talk about the DRG route tables and route distributions. Whenever you create a DRG, two default route tables are going to be created, one for the VCN attachments and one for all other attachments. Although there are two default route tables created, you can create a DRG route table and then you can associate it with the network resource that is attached to your dynamic routing gateway. So that option is always there. And we also talked about equal cost multipath routing in the whiteboarding. So what are the typical use cases of dynamic routing gateway? The first is simplified configuration. We know that a single DRG can have multiple VCNs attached to it. And the best part is these VCNs can belong to the same tenancy or a different tenancy. So in case you want to peer two different virtual cloud networks in the same region, you don't need to set up multiple local peering gateways. Just having one dynamic routing gateway will solve this purpose, and hence simplified configuration. High availability. Using DRG, you can use OCI Fast Connect in one region to communicate with resources in a VCN in another region. Increased scale. A single DRG can have up to 300 local VCNs attached to it. And then using DRG, you can also design transit routing scenarios. So basically, you can create a hub and a spoke architecture. Complex routing. The DRG allows you to specify a unique route table for each attached network. Now, communication between the DRG attachments, that includes virtual cloud networks, is controlled by these routing tables and the associated import policies. So using DRG, we can also support topologies like hub and spoke, which also allows you to use network virtual appliance in a hub VCN to filter or inspect the traffic between your on-premises network and a spoke VCN. So DRG caters to all those complex routing requirements. So this is a quick visualization of how the DRG routing engine works. So first step is when the packet arrives into DRG from the different types of attachments. Then a route lookup is performed on the route table that is associated with the ingress attachment. Now, if it's a VCN, then the lookup is going to be performed in the route table associated with the VCN attachment. Ultimately, the packet is going to be forwarded by the DRG routing engine based on the next hop parameters in the route tables. Alright, this marks the end of this lesson on dynamic routing gateways. So next we have a demonstration on dynamic routing gateway. Please don't miss it, and hope you are enjoying the discussion on networking. Thanks for your time. Hello and welcome to this demonstration on Dynamic Routing Gateway. Let's get started. I'll take you to the OCI console and you see that I am currently in the Phoenix region. So I'll click on the navigation menu, click on networking. Under customer connectivity, I'll click on Dynamic Routing Gateway. So currently I don't have any dynamic routing gateway. So let me create one. I just need to specify the name of the dynamic routing gateway. And I will call it Demo DRG. Click on Create Dynamic Routing Gateway. So I will wait for this DRG to get provisioned. All right, so the demo DRG is now available, and under resources, you can see that there are different types of attachments. For example, VCN attachments, Fast Connect virtual circuit attachments, IPsec tunnel attachments. This is for site-to-site VPN. This is remote peering connection attachments. Then we have loopback attachments, cross tenancy attachments. So these are the type of attachments. And then over here, you see the DRG route tables. And whenever you create a dynamic routing gateway, there will be two route tables that will be automatically created or automatically generated. So you see that this first one, this is the auto-generated DRG route table for RPC, remote peering connection, virtual circuit, and IPsec attachments. And this one is for VCN attachments. One interesting thing that you should make a note of is that for this route table, the import route distribution is auto-generated import route distribution for VCN routes. And for VCN attachments route table, the import route distribution is basically the auto-generated import route distribution for all routes. So if you click on this route table, you see that there is a concept of static routes and dynamic routes. So the static routes, you will be able to see it here if you have added one. For dynamic routes, you have to click on Get All Route Rules. So if you click on Get All Route Rules, you see that currently it says no items found. All right, because currently we don't have an attachment. So I'll click on Close. What I'm going to do next is I'll go to the DRG, click on VCN attachments, click on Create Virtual Cloud Network Attachment, select Prod VCN, and click on Create VCN Attachment. Okay, so now the lifecycle state is attached, and this is the DRG route table. You can also go to the DRG route table from here. So if I now go to this DRG route table, still there is no static rule because I haven't added any. But if I click on Get All Route Rules, now I am able to see two rules getting populated. And what are these two rules? These are basically the subnets inside the VCN that I attached to the dynamic routing gateway. So there are two subnets and hence I am able to see two different routes. So let me return back to the demo DRG. And now if I click on Import Route Distributions, there are two by default import route distributions that are auto-generated. This one is for VCN routes. So if I click on VCN routes, here it says that when there is a match of the attachment type VCN, then it is going to import. Similarly, if I go for this, here it says match all. So let me do one more thing. Let me create another virtual cloud network attachment, and this time I am going to select Test VCN. Click on Create VCN Attachment. And can you guess what's going to happen to this particular route table? If I click on Get All Route Rules. So now you are able to see 4 route rules. Why? Because I have attached another VCN that also has 2 subnets inside it. Okay, so now if I go to this particular route table, you see that the import route distribution is for VCN routes. What it means is, if I go to this particular route table, you see there are no static route rules. If you click on Get All Route Rules, you should be able to see 4 route rules. So for both the route tables, you are able to see 4 rules. This one also, you are able to see 4 rules. Now I will show you one interesting thing. So let me return back to networking. You see that I have a couple of VCNs. I have already attached test VCN and prod VCN. Now what I will do is I will use this prod VCN and I will pair it with another VCN that is running in Sydney. Okay, so let me go back to Phoenix, and this is the VCN that I will pair. So what do I need to do? I need to go to customer connectivity, dynamic routing gateway, demo DRG, and then under remote peering connection, I'll click on create remote peering connection. So I will just give it a name, remote peering connection Phoenix, and I will click on create remote peering connection. So you see that it is currently attaching. Now what I also need to do is I will go back to Sydney. First of all, I will create a dynamic routing gateway. I will name it DRG Sydney. So my dynamic routing gateway is currently available in Sydney. I'll click on create virtual cloud network attachment. I will attach this particular VCN. So after this is attached, I will go to remote peering connection and I'll click on create remote peering connection. So this is RPC Sydney. I'll click on create remote peering connection. Okay, so you see that it is currently attaching. So now you see that the peering status is new or not paired. I need to go to Phoenix, demo DRG. Now let me show you one thing. Let me go back to the dynamic routing gateway route tables. If I click here, you see there is no static route rule. If I click on get all route rules, if I refresh the table, I'm able to see only 4. Click on close. Let me return back to the demo DRG, remote peering connection attachments. And now this is the remote peering connection. This is basically the OSIT for the remote peering connection information. I will copy it and then I will go back to Sydney. I'll go back to DRG Sydney. I'll click on remote peering connection attachments, RPC Sydney. Click on establish connection. Select the region, US Phoenix 1, and just provide the remote peering connection OSIT. Click on establish connection. So let me return back to Phoenix. Click on demo DRG, remote peering connection attachments. Click on RPC Phoenix. Okay, now you are able to see that the peer status is pending. That means the peering is in progress. So I will wait for the peer status to be paired. Okay, now you see that the peer status is paired. So I'll quickly go back to Sydney. So I'll click on networking. I'll click on virtual cloud networks. This is my VCN. And inside the VCN, I just have one subnet. And this is the CIDR block. Return back to Phoenix. Go to customer connectivity. Click on dynamic routing gateway. Click on demo DRG. Click on remote peering connection attachments, and the peering status is paired. So now if I go back to import route distributions, you see that using this rule, which is auto-generated import route distribution for all routes, because this is matching all, and this is the same import route distribution which we are using in case of our DRG route table for VCN attachments. You see the import route distribution is auto-generated import route distribution for all routes. So if I click here, as usual, I don't see any static route rules. But if I go to get all route rules, this time I will be able to see one more route rule, which is the remote peering connection. Now, the interesting part here is if I go back to the demo DRG and if I click on this DRG route table for other attachments, still I don't see any static route rule. But if I click on get all route rules, even if I refresh the table, I'll be able to see only 4 and not 5 because this route table is using the import route distribution and the rule is only VCN routes. You see, the attachment type is only virtual cloud network. In our case, the attachment type was remote peering connection and hence it did not import the route. So one final thing I will show you before concluding this demonstration, you can create an import distribution. You can define the priority, the lower the number, the higher the priority. For example, priority is 1, the match type, attachment type, and you can select the attachment type, or what you can do is you can just select the attachment, or you can click on match all, right? So attachment type, let's say virtual circuit, the action is accept, create import route distribution. So this is how you can create an import route distribution. And then while creating a DRG route table, you can use that import route distribution. We also talked about ECMP in our theory discussion. So this is where you can enable ECMP. All right, this marks the end of this demonstration on dynamic routing gateway. I hope you found it useful. Thanks for watching. Hello and welcome to this lesson on site-to-site VPN. Let's get started. So I will open up a whiteboard and let me first of all explain you what is the meaning of site-to-site VPN. So there are some old names of this particular service. So if you hear VPN Connect or IPsec VPN, these are the old names of site-to-site VPN connection. What does this site-to-site VPN connection do? It provides an IPsec connection between on-premise environment and virtual cloud network. So if this is your on-premise environment, this is your virtual cloud network. So you have a DRG over here, dynamic routing gateway. You have a customer premises equipment over here. So this is the IPsec connection that is established between the on-premise network and the virtual cloud network. Now, what is the meaning of this IPsec connection? This typically represents that the IP packets are going to be encrypted before they are transferred and decrypt when it arrives. So that is what is your IPsec protocol. Now remember, this communication, this happens over the internet. So the traffic traverses over the public internet, but it's an encrypted connection. Now let's look at the two modes of an IPsec connection. So it has two modes. The first mode is transport mode, and the second mode is tunnel mode. Now, before you understand this, you have to understand what is the difference between a header and a payload. Now, header, simply think of it like an envelope or the box. And this payload, think of it like the content or the data. So this header contains information about the packet, things like origin IP, destination IP, but the actual data or the content is what is your payload. So two things, header and payload. Now, if you understand this, you'll easily be able to understand transport mode. Because in case of transport mode, the header, it stays intact. And the IPsec protocol, that is going to encrypt only the actual payload. So this is what happens in your transport mode. Now in case of tunnel mode, it's going to encrypt and authenticate the entire packet. And when I say entire packet, it includes both header and the payload. So why is this important? This is important because Oracle, it supports tunnel mode. So the tunnel mode is supported by Oracle. So now let's talk about what are the advantages of site-to-site VPN connection. The first advantage is it is cost effective. I already mentioned that the communication traverses through public internet, which means there is no need for dedicated lease lines. So it is not required. And hence it is cost effective. The second advantage is it is quick to set up. Usually, if you'd like to conduct a POC, you can very quickly set up a site-to-site VPN connection. The third benefit is that the communication is encrypted. And whenever you create a site-to-site VPN connection, so each connection will have two tunnels. So tunnel 1, tunnel 2. So basically there are two redundant tunnels. And when you are configuring a site-to-site VPN connection, you have different choices with respect to the routing types. You can use static routing, or you can use dynamic routing, which uses your BGP. And then there is also support for policy-based routing. So keep in mind that the routing is configured per tunnel because there are two tunnels. And the recommendation from Oracle is that if there are two tunnels, you have to use or you have to configure the same routing type. Okay, so now let's look at the components of site-to-site VPN. Let me draw a very quick diagram. So this is your on-premises environment. This represents your OCI region. Inside a region, I have a virtual cloud network. I have created a dynamic routing gateway, and the dynamic routing gateway is attached to a VCN. Now on the on-premise side, there is a customer premise equipment, and I'm just representing this as internet. So this is your site-to-site VPN connection. And this site-to-site VPN connection has two tunnels, as I discussed. Now, there are a couple of things that I quickly want to talk about. The first thing is CPE, and I will very specifically talk about the CPE object. When you create a site-to-site VPN connection, you need to provide CPE object. You need to provide the dynamic routing gateway. Actually, on the on-premises side, this customer premises equipment can be either software-based or hardware-based. Actually, the customer premises equipment lies on the on-prem side. But when we are creating a site-to-site VPN connection on the OCI side, then you need to provide a virtual representation of this particular device. And that virtual representation is your CPE object. So virtual representation of customer premises equipment, which actually is on the on-prem side. But we are creating this object on the OCI side. Now this customer premises equipment, it will have a public IP address. And this public IP address can have up to 8 IPsec connections. Now, what is your IPsec connection? When you would like to create a site-to-site VPN connection, you create an IPsec connection. And when you create an IPsec connection, it basically connects the CPE object to the dynamic routing gateway on the OCI side.
So it basically represents a site-to-site VPN connection. I also mentioned that one connection is going to have two tunnels. So tunnel 1, tunnel 2. And this is for redundancy purposes. Now each tunnel is going to have some configuration information. For example, it is going to have a public IP address. It's also going to contain a shared secret. Now, when you are configuring your customer premises equipment on the on-prem side, you require this configuration information. And sometimes what might happen is on the on-prem side, let's say this is OCI, the CPE device may lie behind a NAT device. So this is your NAT device. It has a public IP address. Now, by default, Oracle uses the customer premises equipment's public IP address. But in case the customer premises equipment is behind the NAT device, you need to change the customer premises equipment Internet Key Exchange identifier and point it to the customer premises equipment private IP address. So please note that when it comes to Internet Key Exchange, Oracle supports both Internet Key Exchange version 1 and version 2. So this marks the end of this lesson on site-to-site VPN. Thanks for your time.
Welcome back. Let's now discuss the deck on site-to-site VPN connection. Let's get started. So as I already mentioned, site-to-site VPN connection provides a site-to-site IPsec connection between your on-premises environment and virtual cloud network. And the IPsec protocol is going to encrypt the IP traffic before the packets are transferred, and it's going to decrypt when it arrives. And we also talked about the features of site-to-site VPN connection. For example, it's an encrypted connection. What it means is it's a secure connection between your network and Oracle Cloud Infrastructure. Whenever you create an IPsec connection, it results in creation of two tunnels, which means there is high availability because there are two redundant Oracle routers. And Oracle supports both Internet Key Exchange version 1 and version 2 protocol. So this is what it is. You have customer data center on one side and you have the virtual cloud network on the other side. So you create an IPsec connection, which represents your site-to-site VPN connection. The communication happens over the internet, but it is encrypted. So let's talk about some use cases of site-to-site VPN connection. The first is you can use it for proof of concept. So because there is no contract or no commitment, and the setup is also fast because you don't require any dedicated lines. So you can connect your headquarters, branch locations, and private data centers to Oracle Cloud Infrastructure so that all the sites can access the applications. You can also securely connect your existing infrastructure to the cloud, or you can connect multiple clouds. And if you have Oracle Fast Connect, which we are going to discuss in one of the upcoming lessons, you can also use site-to-site VPN connection to provide a redundant connection. So this is what is your customer premises equipment device. I mentioned that it can be a software, it can be a hardware, and it's deployed in your on-premises environment. So you can see the list of the verified equipment vendors like Cisco, Fortinet, Checkpoint, Juniper, LibreSwan. And I also mentioned that there are two tunnels when you create an IPsec connection. So tunnel 1 and tunnel 2, and each of these tunnels have a public IP address associated with them. and they also contain a pre-shared key. On the Oracle side, you see the dynamic routing gateway attached to a VCN. Now here, you should note that a single customer premises equipment object, public IP, can have up to 8 IPsec connections. So as I already discussed, OCI side-to-side VPN connection, it supports both Internet Key Exchange version 1 and version 2. On the OCI side, there is dynamic routing gateway, which is attached to the VCN. So think of it like a VPN head end at the OCI end. And then there is customer premises equipment on the on-premises side. So that is actually your VPN router. It can be a hardware, it can be a software. And while creating an IPsec connection, you require a customer premises equipment object. So that object is the virtual representation of your router that is there in your on-premise environment. So to create a CPE object, you need to give it a name and specify a public IP address. So when you create IPsec connection, you basically connect your customer premises equipment object and the dynamic routing gateway. And when a connection is created, it results in the creation of 2 IPsec tunnels. From a routing standpoint, I have already discussed that it supports static routing and dynamic routing. You can also configure policy-based routing. This is also something that we discussed. There are 2 different modes when it comes to site-to-site VPN connection, tunnel mode and transport mode. So the tunnel mode is supported by Oracle. So tunnel mode basically encrypts and authenticates the entire packet, which means both the header and payload, whereas the transport mode, as you can see in the diagram, it encrypts only the actual payload and the header stays intact. So when your customer premises equipment is behind the NAT device, because the default Internet Key Exchange identifier is the public IP address of your customer premises equipment, hence, if it is behind the NAT device, you need to configure new Internet Key Exchange identifier, which is going to be the private IP of your customer premises equipment. All right, this marks the end of this lesson. Thanks for your time. Welcome to this demonstration on site-to-site VPN. Let's get started. So let me talk about the scenario that we are going to implement. So we will work with 2 regions. The first one is Ashburn, and then we have Phoenix. So in Ashburn, we will create a VCN and we will name that VCN on-prem network. So we are kind of simulating this virtual cloud network to work like an on-prem network. So this VCN will have 2 subnets, one private subnet and one public subnet. We will create 2 virtual machines. One VM here, we will call it Customer Premises Equipment VM. And this is going to be Ping VM, just for testing. Now on the Phoenix side, we will create a VCN. We'll create a customer premises equipment. We'll also create a DRG and attach this VCN to this DRG. And we will be creating another VM. So let's call it test VM. Now what we are going to do is we will be downloading LibreSwan and installing it on this customer premises equipment virtual machine. So after configuring the IPsec files, we will be able to establish an IPsec connection between the on-prem and our OCI. So this is what we are going to do. So I will take you to the OCI console and see that currently we are in Ashburn region. So we will quickly provision our virtual cloud network. I'm going to use the VCN wizard. Create VCN with internet connectivity. Start VCN wizard. Because we are in Ashburn, so I will name it on-prem network. I'm okay with this CIDR. I will configure the CIDR for my subnets. Okay, rest everything remains the same. Click on create. Okay, so my VCN is now created. On-prem network VCN with 2 subnets. Private and public subnet. So now I will launch my instances, one in public and one in private. So click on create instance. I will call it CPE VM. Everything remains the same. I will deploy this in the public subnet. I will paste the public keys and I will click on create. So while it is creating, I will go to attached VNIX. I'll just click here, edit VNIC, and I'm going to click on skip source destination check. Click on save changes. Okay, so this is the first VM. I will create another VM and I will call it ping VM. I can create it in private subnet. I will paste the public keys and click on create. So you see that both these VMs are getting provisioned. So I need not wait for it. What I will do now is I will go to Phoenix and here I will provision a virtual cloud network. I'll click on Start VCN Wizard. VCN name is going to be OCI VCN. So I'll provide this CIDR. Okay, I'll click on next, click on create. So this VCN is now created. So I'll go to the compute, click on instances. I'll click on create instance. I'll name it test and I will deploy it in the public subnet. I'll just paste the keys. Click on create. Okay, so this is getting provisioned. We don't need it right now. So now what I will do, I will go back to Ashburn and now I see that both these VMs are up and running. What I will also do is I will make a note of the public IP address of my customer premises equipment VM. So my public IP is, so this is my public IP and my private IP is, okay. So this is the information that I require. I will go back to Phoenix. Let me create a dynamic routing gateway. So under networking, Under customer connectivity, I'll click on DRG, create dynamic routing gateway. Just name it DRG, click on create. The next step is I need to create a virtual cloud network attachment. So this is the OCI VCN. Click on create VCN attachment. Now I will create the customer premises equipment. Click on navigation menu, networking. Under customer connectivity, click on customer premises equipment. To create customer premises equipment, I need the public IP address of my customer premises equipment VM, which is running in Ashburn. So I'll copy it. I'll return to the Phoenix region. Click on create CPE, demo CPE, and this is the IP address. The vendor is going to be LibreSwan and the platform is 3.18 or later. Click on create customer premises equipment. Okay. The next step is I will go ahead and create the IPsec tunnel. So click on networking. Under customer connectivity, click on site-to-site VPN. Click on create IPsec connection. IPsec connection. Select the customer premises equipment that you created. Select the dynamic routing gateway. And here you need to provide the on-prem CIDR. In our case, the on-prem CIDR is 10.0.0.0/16. Just give a name to the tunnel, tunnel 1. Select static routing. Similarly, tunnel 2, select static routing. Click on create IPsec connection. So my IPsec connection is getting provisioned. So this marks the end of the first part of this demonstration. In the next part, I will show you how you can create a site-to-site VPN connection. Thanks for your time. Welcome to part 2 of site-to-site VPN connection demonstration. So in the previous demonstration, I had created an IPsec connection. So let's continue from there. As you can see, there are two tunnels. So I'll click on tunnel 1. You see that under tunnel information, there is shared secret. So I'll click on edit and I will just provide secret 1. Click on save changes. I will return back to IPsec connection. I'll go to tunnel 2. Click on edit. I'll provide secret 2 as the shared secret. Click on save changes. I'll go back to the IPsec connection. So now the thing that you should note here is that the lifecycle state for both tunnel 1 and tunnel 2 is available. You see both are available, but the IPsec status is down because as of now we haven't configured the IPsec files. So what I will do now is I will go back to Ashburn and connect to my CPE VM. I'll launch Cloud Shell. So I'll connect to the CPE VM. So you see that I am successfully able to perform SSH into this CPE VM. Now I will be downloading LibreSwan. So I'll run this command. So you see that LibreSwan installation is successful. Now I will be configuring the IPsec files. So I'll be configuring 3 files. So the first file is this one, sysctl.conf. So this was the first file. Now I will run the command for these modifications to take effect. Okay, this is done. Now I will be configuring the second file. So you see here, this is how this file looks like. So what I will do is, here I will have to put the public IP address of my CPE VM. So I'll just copy it and put it here. And this is the tunnel 1 IP address. This is the tunnel 2 IP address. So I need to go to IPsec connection and just copy the tunnel 1 IP address. So this is the tunnel 1. And the tunnel 2 is this .238. And my secret is secret 1 and secret 2. So this is the one. I'll just copy it and I will put it here. So the second file is also done. Now let me create the third file. So this is going to be the third file. You see, this is for tunnel 1 information. This is the private IP address of the customer premises equipment. This is the public IP address, and this is the tunnel 1 public IP. Similarly, you see for tunnel 2, this is the same private IP address of the CPE VM, public IP address of the CPE VM, and this is the tunnel 2 public IP address. Okay, so I'm all done. So I will just restart the IPsec service. Okay, so it's done. So now I will configure the route to OCI. Okay, so at this stage, the IPsec tunnel status must have changed to the up state in the Phoenix region. So let me go there, and you see that the IPsec status is up. So this concludes the second part of the demonstration on site-to-site VPN. In the third part, we will test the connectivity between OCI and on-premises VMs. Thanks for watching. So welcome to this third part of the demonstration on site-to-site VPN. So our configuration part is already complete. The tunnel 1 and tunnel 2 status is up. So both the tunnels are up. Now what I have done is, if you go to the VCN, I have configured the security rules and route tables, and I will show you what exactly I have done. Click on on-prem network. If I click on security list, so in both the security list, I have added this particular rule, the last one. This is the source, right? This is our OCI side. And IP protocol ICMP, we are allowing ICMP traffic. Same is the case with this private subnet. Same rule. And what we have also done is, we have added a route rule for the route table. The destination is the OCI side, the target is the private IP, and this is the target. This is the private IP address of my CPE VM. And that's the reason why we disabled the source destination check. So these are the settings on the on-prem side. And let me open a duplicate tab. I will show you the settings on the OCI side. So I will go to networking. I'll go to the VCN, OCI VCN. If I click on security list, the default security list, I have added an ingress rule for this particular source, which is nothing but, which is the on-prem side, and allowing ICMP traffic. And the default route table, this second rule is what I added. The destination is on-prem. The target is dynamic routing gateway, and it is a static route. So this is the OCI side, Phoenix. If I copy the private IP address and I return back to Ashburn, I try to ping the private IP address on the OCI side. So you see, this works. Let me also try the reverse. I can connect to this particular public IP. Let me do that. I will launch Cloud Shell. Okay, so now I am connected to this test instance on the OCI side. Okay, so if I grab the private IP address of the ping VM that's running on the on-prem side and ping it from here, ping it from Phoenix, you see that it is working. So this means that we have successfully tested the connectivity and our site-to-site VPN connection is working properly. So this marks the end of this demonstration on site-to-site VPN. I hope you liked the demonstration. Thanks for your time. Welcome to this lesson on Fast Connect. Let's get started. So what exactly is Fast Connect? Let's assume this is your on-premises environment and this is your OCI, Oracle Cloud Infrastructure. So by Fast Connect, we mean a dedicated and private connection. So it's a dedicated and private connection between your on-premise environment and Oracle Cloud Infrastructure. And what is the implication of having a dedicated and private connection? The first implication is it provides higher bandwidth options. And because it is a private connection, it is more reliable, it is more consistent from a network experience standpoint. So higher bandwidth, more reliable, and more consistent. Now let's have a look at some of the concepts associated with Fast Connect. Now the first concept is with respect to the Fast Connect itself. We have already discussed this. Fast Connect basically means there's a private physical connectivity between OCI and your on-prem network. So that is your Fast Connect. Now the second concept is with respect to Fast Connect location. So this Oracle Fast Connect location is an Oracle data center where you can connect to Oracle Cloud Infrastructure. The third concept is metro area. What is this metro area? This is a geographical area with multiple Fast Connect locations. Let's say this is Fast Connect location 1. This is Fast Connect location 2. So it's an area with multiple Fast Connect locations. Now let's look at the fourth concept, which is Oracle partner. The fifth concept, so I'll cover the fourth one and the fifth one together. So let me also write the fifth one. This is a third-party provider. So what is the difference between an Oracle partner and a third-party provider? First of all, both these are network service providers. So both these are network service providers, but in case of Oracle Partner, this one, Oracle Partner, has integrated with Oracle in a fast connect location. So Oracle Partner has already integrated with Oracle in a fast connect location. Whereas in the case of a third-party provider, this is a network service provider which is not on the list of Oracle partners. So both these are network service providers. One is integrated with Oracle in a fast connect location, that is your Oracle partner, and the third-party provider is not an Oracle partner. This is the difference between Oracle partner and third-party provider. Now, why is this important? Because in the upcoming lessons, we will talk about the different connectivity models. So you should have a very good understanding of the difference between an Oracle partner and a third-party provider. Now, the sixth concept is co-location. We talked about a fast connect location. So in a fast connect location, there is usually an Oracle cage, and inside the Oracle cage, there are Oracle Edge servers. By co-location, I mean that your equipment is also deployed in a fast connect location. So what it means is that you also have a cage. And inside your cage, you have your edge servers. So that is the meaning of co-location. That means your equipment is also deployed in a fast connect location. Now the next concept is cross connect. So cross connect is the physical connection aspect in a fast connect. Now note that in fast connect, we have a physical connection as well as a logical connection. When I say physical connection, you should understand that it's basically a cross connect. And when I say logical connection, it is basically a virtual circuit. So please make a note of this, that there is a physical connection and then there is a logical connection. Physical connection is your cross connect and logical connection is your virtual circuit. What does this cross connect basically mean? It means that there is a physical cable. So this is the cable which is connecting your network to Oracle in a fast connect location. Then the eighth concept is very much related to cross connect, which is your cross connect group. So as you require more bandwidth, you might need to enable a feature which is cross connect group. That means it's a collection of cross connects. And when will you use it? When your bandwidth needs increase. Now the ninth concept is dynamic routing gateway. How is dynamic routing gateway related to fast connect? First of all, I mentioned that the logical part of the fast connect connection is a virtual circuit. There are two types of virtual circuits. One is public and the other one is private. When there is a dedicated connection between your on-premise network and the public OCI services, we typically use a public virtual circuit. And when there is a private communication between your on-premises environment and a virtual cloud network, that is what is your private virtual circuit. Now we know that a VCN can have a dynamic routing gateway attached to it, and hence a dynamic routing gateway is necessary for private peering. In case of public peering, the DRG doesn't come into action. Now the 10th concept is with respect to virtual circuit. We know that this virtual circuit
is a logical concept when it comes to Oracle Fast Connect. And this represents an isolated network path. So ultimately, this virtual circuit, which is logical, is going to run over the physical network. So if this is our physical network, think of this like a logical or virtual circuit. So it's basically an isolated network path. And the virtual circuit, it comes in two flavors: private virtual circuit and public virtual circuit. Now the 11th concept is with respect to BGP session. So what is the meaning of BGP session? Let's say there are two different autonomous systems, and these autonomous systems, they exchange routing information. So this exchange of routing information is known as BGP session. Now the next concept is something that is known as BFD. BFD stands for bidirectional forwarding detection. So what is this BFD? It simply verifies connectivity
between devices. So it is least interested, or it does not exchange routing information. It simply verifies connectivity between devices. So what it typically means is that it is a kind of method for detection of failures. And what kind of failure am I talking about? Between adjacent networks. So it is going to verify the connectivity between the devices and identify failures. Now we are going to discuss about Oracle Edge. Now in the architecture, when we discuss connectivity models, you'll hear me talking about Oracle Edge. So what is this Oracle Edge? Let's say this is your Fast Connect location. In Fast Connect location, there is an Oracle cage. And inside Oracle cage, there is an Oracle Edge. And this Oracle Edge is nothing but this is going to have a physical device as well as a logical device, because we know that there is both a physical and logical aspect in Fast Connect. So this is going to be our 14th topic, and this is going to be our 15th topic. Now let's try to understand what is this physical device all about. So physical device is a Fast Connect device that terminates the physical connection. And what is the physical connection? It's the cross connect. So the physical connection is going to be terminated on the physical device. And what is the logical device? The Fast Connect device that is going to terminate the logical connection, meaning the virtual circuit. So these are the physical and logical devices. Now we will talk about the last concept, which is LOA. LOA stands for Letter of Authorization. Now to help you understand this, I will again draw this Fast Connect location where there is an Oracle cage and there are Oracle logical and physical devices. In case you are working with an Oracle partner already has established the physical connection with Oracle in a Fast Connect location. So for partner, this LOA is not applicable. But in case of a third-party provider, because this provider is not on the list of Oracle partners, so it does not have a physical connection in the Fast Connect location. So in order for you to help the third-party provider facilitate the physical connection in a fast connect location, Oracle is going to give you a letter of authorization that you can hand it over to the third-party provider, and the third-party provider will then lay the physical connection in the fast connect location. So that is the case of a third-party provider. There is another model. So this is first, this is second, this is third. The third model is co-location. So in case of a co-location, your edge servers are also deployed in a fast connect location. So this is basically your cage. Still, in case of co-location, the physical connection needs to be established, meaning the cross connect needs to be established. So for you to establish this cross connect, again, Oracle is going to provide you a letter of authorization, but this time, because there is no third-party provider, you need to provide this letter of authorization to the fast connect location data center technician. And that person is going to help you complete the provisioning of the physical connection. So it's basically a letter that provides authorization to another party within a data center. And which data center are we currently talking about? We are talking about the fast connect location data centers. And this letter of authorization, it is not applicable in case of a partner. It is only applicable in case of a third-party provider and co-location. And we are going to look at the connectivity models in the next lesson. So I hope you understand what is a fast connect and what are the important concepts related to fast connect. Thanks for your time. Hello and welcome to this lesson. Let's talk about the connectivity models now, and connectivity models with respect to OCI Fast Connect. So there are three connectivity models. The first one is Fast Connect with an Oracle partner. The second one is Fast Connect with a third-party provider. And the third one is Fast Connect co-location with Oracle. When you create a Fast Connect connection in the OCI console, you will see an option for this. For these two, the second and the third, you have to select Fast Connect Direct. There will be two options, one for Oracle partner and then Fast Connect Direct. Fast Connect Direct is going to have these two options, either third-party provider or co-location with Oracle. So let's look at these one by one. So first will be the Fast Connect with an Oracle partner. So I am drawing a data center here. So this is the data center, customer data center. This is the Fast Connect location. And this is OCI. There is a customer premises equipment on the data center side. And inside the Fast Connect location, this is basically the edge, or you can call it the Oracle cage. Inside the cage, this is the edge. So this is the Oracle Fast Connect edge. Now we have discussed in the previous whiteboarding what is an Oracle partner. An Oracle partner is a network service provider that has already established connection with the Fast Connect location. So what it typically means is this is the edge. This connection is already established. Now what you need to do? So you need to work with the Oracle partner and establish this physical connectivity. So what does it mean? It means that in case of an Oracle partner, there is no concept of letter of authorization because this connection is already established. You just need to work with the partner and provision a physical connection from your data center to the partner edge, which is already there inside the Fast Connect location. So you can think of it like the partner network. So this is what is your Fast Connect with an Oracle partner. This is how the architecture looks like. Now let's look at the second option. So the second option is Fast Connect with a third-party provider. Again, I will draw the three constructs. Customer data center. This is the Fast Connect location. And this is OCI. Now here in the Fast Connect location, this is the Oracle cage. So this connection is already there. Now in case of the third-party provider, you need to work with a carrier of your choice. So you can decide on the network service provider or the network carrier. So you decide on the network carrier of your choice. And this network carrier is responsible for physical connection between the on-premises and the Fast Connect edge. So the network carrier is responsible for providing physical connection between the on-premises and Oracle Fast Connect edge devices. Now in this case, we do require a letter of authorization. Oracle will provide you the letter of authorization, and you need to forward this letter of authorization to the third-party provider, because ultimately this third-party provider is going to perform the cross connect. In this case, you are ordering a private or dedicated circuit from a network carrier, which is not an Oracle partner. Now let's look at the final one, which is Fast Connect co-location with Oracle. So let me once again draw it. This time I will draw the Fast Connect location and OCI. So this is the customer data center. So this is your cage. This is Oracle cage. So there are physical and logical devices inside the cage, and inside your cage there will be edge device. So in this scenario, you already have a presence at an Oracle Fast Connect location. You see your edge servers, your cage is already there in the Fast Connect location. So what is the only thing that you need to do here? So Oracle will give you a letter of authorization that you need to provide to the data center provider. And after providing it, a direct cross connect is going to be established. That means a physical connection. So it's a direct connection via fiber cross connect. And the connection is happening between your cage and Oracle cage. So this is what is your co-location with Oracle. So this marks the end of this lesson where we discussed the three types of connectivity models. Thanks for your time. Hello and welcome to this lesson on Fast Connect overview. So it's time to go through the deck. So as we discussed, Fast Connect is a dedicated and private connection between on-premises network and Oracle Cloud Infrastructure. It provides high bandwidth and caters to latency-sensitive applications. So when you are working with Fast Connect, there is no egress data transfer charges. So as you can see here, we can connect the on-premises data center with Oracle Cloud Infrastructure using a dedicated and private connection, which is your Fast Connect. So Fast Connect has different connectivity models, basically three. The first is using an Oracle partner. The second is using a third-party provider. And the third is co-location with Oracle. So as we discussed, in case of Fast Connect, the communication is private and it's a dedicated physical connection. So the data does not traverse the internet. And there are two types of peering that you can configure. Basically talking about the logical side of fast connect or virtual circuits, you can have private peering, which means you are extending your on-premise infrastructure into a VCN. And for this, you require a dynamic routing gateway. And then there is a concept of public peering, which means you are connecting from the on-premise network to the OCI public services in Oracle Cloud Infrastructure without using the internet. So that is what is your public peering. And in the whiteboarding section, we have discussed all these concepts. What is a fast connect location? What do you mean by a metro area? Basically a collection of fast connect locations. What is an Oracle partner? What is a third party provider? What do you mean by co-location? What is cross connect or the physical connectivity? What is a virtual circuit or logical site of fast connect? What is a physical device? What is a logical device? And what do you mean by a letter of authorization? Who issues it? In which connectivity models is the letter of authorization issued? So we have discussed all these things. Now let's move on to the fast connect connectivity models. So the first option is fast connect with an Oracle partner. So in case of Oracle partner, there is a pre-established physical connectivity with OCI. You basically need to form a relation with partner and establish the connection between your on-premises network to the partner edge inside the Oracle Fast Connect location. So out of the three, this is the least expensive and the most flexible model. So the second option is Fast Connect Direct co-location. In this case, the customers already have presence in the Fast Connect location. So what you need to do here is that you just need to establish a connection between your cage and Oracle cage. And this is a good model if you already have presence in the Fast Connect location. The third option is Fast Connect Direct with a third-party provider. So here you work with a network carrier of your choice to get a physical connection from your data center to the Fast Connect location. This is a good model if you are already working with a network carrier and if your data center is not being served by any of the Oracle's Fast Connect partners. So this marks the end of this lesson on Fast Connect overview. Thanks for your time. Welcome to this lesson on Fast Connect with an Oracle partner. Let's get started. So as you can see in this architecture, this is the OCI region where we have a VCN, private subnet and public subnet. And then this is the Fast Connect location where there is Oracle cage with the edge device. What you see on the left side are the customer data centers with the respective customer premises equipments. Now, in case of a partner, the partner has already established redundant cross connects with the Fast Connect edge devices, and hence there is no need for any letter of authorization. So in this connectivity option, you need to work with the partner to provision the physical connectivity from your data center to the partner edge device. Now let's look at the steps that you need to perform in case of Fast Connect with an Oracle partner. So the first step is where you need to order the connection from the Oracle partner. And keep in mind that it may take some time depending on the partner. Now we know that in case of Fast Connect, if we are talking about the logical connections, there is a private virtual circuit and there is a public virtual circuit. So in case you are setting up a private virtual circuit, or if you plan to use a private virtual circuit or private peering, then you also need to set up a dynamic routing gateway. Then you need to set up virtual circuits. So you can create one or more virtual circuits for your Fast Connect connection. And whenever a virtual circuit is created, an OSID is going to get generated. So in the next step, you need to contact the partner and give the OSID for each virtual circuit that you created. Now the partner is going to then configure each virtual circuit on their end to complete the connectivity. In the fifth step, you need to configure your edge. So there are two possible scenarios here. The BGP session can go to Oracle, or the BGP session can also go to the Oracle partner. So there are two options, and depending on it, you need to configure your edge or your customer premises equipment to use the BGP peering information. Now in the sixth step, you need to confirm that for each of your physical network connections to the partner, the light levels are good. You also need to confirm that the interfaces for the connections are up. Now I mentioned about the two scenarios. The BGP session can go from your edge directly to Oracle, or the BGP session can go from your edge to the partner edge. Now, if the BGP session goes from your edge to Oracle, you need to ping the Oracle BGP IP address and confirm that the BGP session is established. Now, if the BGP session goes from your edge to the Oracle partner, then you need to ping the Oracle partner's edge. You also need to confirm that the BGP session to Oracle partner is established. After that, you also need to ping the Oracle BGP IP address. And finally, you will test the connection. So these are the steps when it comes to configuring Fast Connect with an Oracle partner. So this marks the end of this lesson. Thanks for your time. Welcome to this lesson on Fast Connect with a third-party provider. Let's get started. So as you can see in this architecture, there is an OCI region. There is Fast Connect location where you can see the Oracle cage and the Fast Connect edge devices. So in this connectivity model, you work with a network carrier, which is basically the third-party provider. That means it is not an Oracle partner. And the third-party provider or the network carrier is responsible for physical connection between the on-premises and Oracle Fast Connect location edge devices. So as you can see here, the private circuits via a network carrier. So primarily there are two physical connections. The first connection is going to be from the on-premises or the customer data center to the provider. And the second connection is going to be the physical fiber connection or cross connect that the third-party provider will set up in the Fast Connect data center on your behalf. So when it comes to Fast Connect with a third-party provider, you need to work with a third-party network provider or third-party network carrier. And the carrier is responsible for the physical connection between your on-prem network and the Fast Connect edge devices in the Fast Connect data center location. In this case, Oracle will provide you a letter of authorization, and you need to provide that letter of authorization to the carrier or the third-party provider. And the third-party provider is then going to provision the circuit for you. And in case you already have an existing relation with a third-party provider, or there can be a scenario where the Oracle partners currently is not serving your data center, you can go for this type of connectivity model. So let's look at the steps that you need to perform to set up the Fast Connect with a third-party provider. First of all, if you are working with a private virtual circuit, then you need to create and set up a dynamic routing gateway. The second step is you will set up your cross connect group and cross connect. So after setting up the cross connect group and cross connect, you will receive a letter of authorization from Oracle, and you need to forward that letter of authorization to the third-party provider. So after that, the third-party provider is going to request cabling at the Fast Connect location. After the third-party provider completes the setup of the physical cross connect in the Fast Connect location, you need to confirm from your side that the light levels for each physical connection are good. You also need to confirm if the interfaces are up for each cross connect. Now, when your physical fiber cables in the Fast Connect locations are set up and ready to use, you need to activate each cross connect that you have set up earlier. And this process of activation actually informs Oracle that the physical fiber cable is ready. After that, you can set up your virtual circuit. That means you can create one or more virtual circuits for your connection. The next step is where you configure your edge routers to use the BGP information. You will then ping the Oracle BGP IP address and confirm that the BGP session to Oracle is established. After you confirm this, you can then test the connection. So this marks the end of this lesson. Thanks for your time.